In this video, I'm going to extend upon what we had just covered in lesson 3, which was how to make variables, how to declare them, how to initialize them, with a tutorial on the two types of data that you can have in a Java program. They're called primitives and complex objects. A Java primitive is one of 8 different data types, and I have a list of those here on the left-hand side. They are byte, short, int, and long, which are all the whole numbers that you can store within a particular range. Then you have float and double, which represent decimal values. A Boolean can be either true or false. It's a 1-bit value. And char represents a character. It's a Unicode value that's basically between 0 and 65,000. So let me just go back through these first 4 and clarify their differences. A byte is actually an 8-bit value, and that 8 bits can be between -128 and +127 in decimal form. A short represents a 16-bit number, so it's binary. Its decimal form would be basically -32,000 to +32,000. And an integer is a 32-bit number, so it goes from -2 billion to +2 billion. And a long is a 64-bit number of -9 quintillion to +9 quintillion. So the difference here is how much storage you're taking up in storing that value, and the ranges are significantly different. So again, that's 8 bits, 16 bits, 32 bits, and 64 bits. The floating point, or the float and the double primitives are different in the number of decimal places that they can store. So if you need to store a lot of precision for a decimal number, for instance, you're trying to calculate pi as accurately as possible, you're going to be leaning towards a double value. But if all of the decimals that you're storing in your program, let's say, only have 2 decimal places, then you can save yourself some space by choosing a float as its data type, because you only require 32 bits of information to store that value. So those are your Java primitives. Complex objects, I've put a couple of examples here on the right-hand side, and today we're going to be getting into the scanner and math examples. So a complex object, notice the first letter is capitalized because these are all classes. And over here, all of these primitives were lowercase. And that's because these primitives actually come from helper classes that belong to the java.lang library. And that library is installed by default because everybody's going to use them in their programs. So if you want to use other complex objects from other libraries, you're going to have to import them though. So let me go through some examples in Eclipse. So I've pre-made a class here called Java Primitives, and I put a main method in it so that we can test run some of the things that we're going to do. And let's start off with a quick review of lesson 3, which was how to make a variable. So the syntax, or the proper way to make a variable, was first you specify its data type. Then following that, you put the name, and then after that, if you wanted to give that variable a value, use the assignment operator, which is the equal sign. And then you can give it a value, which can also be an expression. An expression is simply whatever combination of symbols it takes to calculate a value. And then you always have to finish with a semicolon, and that whole line would make a statement. All right, so that is the general format for making a variable. Let's start off with the byte. All right, so a byte was the smallest primitive value in the whole number range, and it goes from -128 to +127. So it has 256 possible values. And the format here is data type, name, which I'm calling this small, and then I'm assigning it a value, and I'm giving it a literal value here of 128. And because I put the semicolon here, that makes it a complete statement. Now the computer can execute this whole thing, which means take this value, store it in a memory address that we're calling small. And now throughout this main method, I can call small, and it knows that it's going to be this value unless I change it later on. Okay, let's look at a couple other primitives, such as short, int, and long. So a byte, again, is a 8-bit value. Short is 16 bits. So it has a bigger range, which means I can put a bigger number in this variable. So I have some examples here of basically each of the whole number primitives. Small, medium, large, and extra large are the names that I've given to them. One more thing that I want to point out about these is that if you have a long value, you have to put an L at the end, and that could also be a lowercase l, but sometimes I think that gets confused for a 1, so I use an uppercase L so there's no confusion. Okay, if I wanted to output those values to the screen, I could use the system.out.println that you saw in the previous tutorial. So println will print an entire line and then move the cursor in the console to the first character in the next line. So if I wanted to print small, I could print it like this, and then I'm going to push play, and then here I can see the value outputted to the screen. And then if I copied this a couple more times, and then I change this to medium, and this to large, and then this to extra large. And remember that Java is case sensitive, so this uppercase L would mean get this variable right there, but if I were to change this to a lowercase l, it wouldn't know what I was talking about. So it has to be an uppercase L. Go ahead and push play, and here I get each of the values that they're storing in these variables. Now there are things called helper classes that will come up later on in our class. And a helper class for these primitives is basically the same name but an uppercase letter. So the class that this comes from is called byte. It's just loaded into the Java programming environment by default. We don't have to call the java.lang library. It's assumed that everybody needs it. And it has things in it like the max value. So this would be the maximum value that a byte can hold. And if I just copy this right here and put this beneath it, I have a variable called sm, med, lg, and xl. And now this will print out basically the opposite end of the range. So here I have the maximum value that each one of these can hold. And just as there was a maximum value, if I did the name.prefix of this class, here's all the different things I can do within this. And the other one here that we could do is min value. So this variable called sm could be the same value as small. So if I did this again, here you can see it printed it out in the console twice. So I'm going to change that back to max value. And those are called helper classes. Another one that we'll use in there would be the method try_parse. And just a quick example of the parse method, because all of these primitives have a helper class with a parse method in them. I'll just do the byte by an example. So I'm going to make another variable that is of the byte data type, and I'll call it temp. And it's going to hold the value of whatever I try to parse here as a byte. So I'm going to call the helper class dot, which is that name.prefix that I introduced to you in the previous video. So byte dot, and then instead of getting max value or min value, there's a method called parse byte. And notice the format is I'm going to give it some parentheses, and then in between the parentheses it wants me to put in a string, which is a bunch of characters. So let me show you how to do that. I'm going to push enter so it auto completes, and then in between double quotes I'm going to put a number, and this is a string. So instead of actually being a number, this is represented in characters. So if I can parse the number 1 as a byte, basically this is going to turn that string into a number and store it in this temp variable. So then let's just try to print it out. So system.out.println temp, and if that works, then we're going to print it to the console, and here it is, 1. However, if it can't parse it, it's going to give us a problem. So here's a number that's bigger than the range of what a byte can hold. Remember, a byte can only go to 127, so if I try to print out 128, it's going to give me an error message down here. Okay, so let me go ahead and just delete this for the time being, and now let's talk about decimal numbers. So decimal numbers can either be a float or they can be a double. And when you create a decimal number, you have to keep in mind that the computer can only either store 32 bits of information or 64 bits of information, which means at some point it's going to truncate that number. So here I've created a floating point version of pi and a double version of pi. Float can store up to 32 bits of information and double can store 64. Now what's going on over here is the math class is imported by default in the java.lang library. So we don't have to import that either. Just like we don't have to import byte, short, integer, or long. It just comes with the language by default. And it has a bunch of stuff in it that we can use. Pi is one of them. And it comes back as a double value. So anytime that something is 64 bits of information and you try to put it in a box that can only hold 32 bits of information, we're going to need to cast it. Now if I took this away, it's going to say, hey, you can't do that. This 32-bit box cannot hold a 64-bit box. So we have to do something called casting. This means make this into one of these if you can. And what's going to happen is it's going to try to slice off the end of the number. That's called narrowing. And the reverse of that is if I take a float, which is a 32-bit number, and try to put it in a double, that's called widening. There's more room in there than I actually need. But that's what's happening here, and we'll do more examples in the future. So let's just print out pi both as a float and a double and just see what happens. All right, so here's the float version of pi, and here is the double version of pi. And here you can basically see the difference is in precision. This just has more precision with pi as a double than it does with a float. Now, another thing that can happen with decimal numbers is called rounding error. So I'm going to show you a quick example of that. And let's say I have a number of 0.7. And whenever I have a literal number, so I'm actually saying 7, it's not a variable, and I have this period in front of it, the period is used throughout the language to indicate either you have a property or a method. So I have to put a D next to this. And that indicates this is a double value. So it's going to store this. But what if I took this value and multiplied it times 3? Well, we would expect that to be 2.1. But because the computer is limited on how it can store a decimal value like pi with a certain amount of precision, and some numbers cannot be converted into binary as well as they can in, let's say, decimal form, the computer has to represent a number as best it can. So let me show you what happens when I multiply 0.7 as a double times 3. I don't get 2.1, I get its best representation of that, which is 2.0999999, and then finally a 6 at the end. So it's not the expected answer, it's a representation of that. So imagine if you were compounding interest and you were off by this little bit and then you multiplied it 1,000,000 times. That's going to be a lot of money that is going to accumulate. So it's something that you have to keep in mind whenever you're dealing with doubles and floats. It's called rounding error. Okay, the last two primitive data types are Booleans and chars. So we're going to fly through those. A Boolean is either true or false. So I can just say the data type is Boolean, this is the name of my variable, and it is holding a true value. I can also change its value to false, and that would just simply say the name of the variable, which I happen to call is true. And whenever you name a variable, you should have this is or has prefix to it, indicating that it is one of two values. And if ever I wanted to switch it to the other value, I can do what's called reversing it. So this is the bang operator, and it reverses the value of whatever Boolean you have next to it. And this could also be an expression, but in this case I have a variable, and it on the previous line was false, so this would change false to true. Okay, so that's Boolean values, and a char variable represents a Unicode character. So a character, or a char, has to be given a single character value, and that's done with single quotes. So a lot of times I see students confuse double quotes with single quotes when using a char value. Just memorize up front that these take single quotes. So if I were to actually print these out using some print line commands, I'm going to print first, second, and third, and I should get A, B, C, just like that. That's how we string together text. And an interesting thing that I could do to this is if I said, let's say first, first plus plus. This is a increment operation. And then I tried to print this out again. Notice how I got a B at the end. And that's because these letters actually they're representative of Unicode values, which means those two are a number between 0 and a little over 65,000. That's how they map characters to symbols, is with these character maps, and each character map rarely represents a number. Okay, so those are all of the primitives. Here's a couple more things that you'll need to know, and that is escape sequences. An escape character is an invisible character that kind of goes along with the char stuff up here, and you might see these inside of a print line statement. And the more common ones that I use all the time are new line, and I'll use these double quote escapes. So I'm going to show you an example of that where I've got this quote of this Latin phrase, and I'm going to separate it onto multiple lines using a \n, and I'm going to put quotes within quotes. So notice how a string has to start and end with a quote. So how do you put a quote within a quote? You use an escape character. So these two escape characters mean ignore the fact that I'm putting a quote here, just put a quote in here when you print it. And I'm going to go ahead and push play, and here it says on 3 separate lines, in Latin, this phrase means, I think, therefore I am. Okay, so lastly, let's talk about other types of operators that you can use. Now, I already showed you an example of one, which was the increment, But if I were to actually write that out, I could have this variable that I'm calling number, and then I could add, subtract, multiply, or divide to it. A lot of times people are introduced to modulus for the first time in my class, so a modulus or a modulo basically means that you want the remainder of two operands. I want the remainder of what these two evaluate to. So for instance, 5, if I were to divide 5 and 10, that divides evenly, so there's no remainder. The increment and decrement operations. An increment can easily be done, instead of actually saying number equals number plus 1, I could shorten that up as I did before with number plus plus. I could also decrement, which means go down. So this would be subtracting 1 from the value of number. I could use compound assignment, which means I can say times equals, or plus equals, or minus equals, or divide equals, or modulus equals, and get the same thing. So that these are shorter versions of what we're doing up here. And one other thing that could take place is called concatenation. So concatenation is when you take a string. So here's a literal string. This is a bunch of characters that I've strung together, and then I put a plus sign next to them. Well, normally speaking, we would logically say, how can you add words and a number? Well, this tells the computer, take this string and merge it with the value of this variable. So this variable will be converted into a string, and then it's going to print number equals whatever it is. So I'm going to go ahead and push play, and it says number equals that value. And that's called concatenation. All right, lastly, we're going to talk about storing input and getting input from the keyboard. So let me show you an example of that. All right, so I have this thing called scanner, and this is what we're going to use to get stuff from the keyboard. So I'm going to call my scanner input. So this is a variable name, and its data type is a complex object called scanner. And I'm going to use the assignment operator to make a new copy of the scanner class, and it takes in system input, which is basically keyboard input. And originally, I already had this imported at the very top of my code, import java.util.scanner. So that's where the scanner class comes from. If I delete this and click save, I'm going to have an error in my class. So let me scroll down to here again, and I want to show you a fast way to put this in. I have this keyboard shortcut memorized because I use it so frequently. It was one of the first things I learned when I learned Java. So under the source menu is this thing called Organize Imports. Notice the keyboard shortcut right here. It's Control-Shift-O on a PC, Command-Shift-O on a Mac. When I click that, it's going to import classes that I need. So it's looking for complex objects like this that it needs to import at the top of our code. And then if I scroll back to the top, it put it right back in there. And if there are classes that it doesn't need to import, it'll take those out. So I'm going to go ahead and click save, and the error message will go away. So back down to the bottom of the code. All right, so this is going to be our way of getting input from the keyboard. Now we can output to the screen, enter a number, and then to store that, I'm going to store it as an integer, and I'm going to call whatever they type, which is an unknown right now, I'm going to call it request. To get that, I'm going to use my scanner and use the name.prefix that I've been mentioning in this video and my previous video. So the name.prefix, let me just retype it right here. Input dot, and then I could import an integer. I could get a byte. I could get a short. Basically, there's all kinds of stuff that in here that I can get. So notice how there's a next float, next double. I could get all of that types of information, but I really only need this one right now. So I'm going to go ahead and just put a semicolon at the end of that, which makes it a complete statement. And now let's find out if whatever they entered was a even number or an odd number. And this is just an example of how to use modulus again, because I find it to be just good practice. All right, so if I need to know the difference between an even and an odd number, I can just divide something by 2 and find out if there was a remainder. If there was a remainder, then that means it's an odd number, but if there was no remainder, then that means that it's an even number. All right, so we're going to take request, find out what it is, and then this will evaluate to either be a remainder or not. And then finally, the last operator that we'll discuss here is the double equals. Double equals is a test of equality. Up here, this is assignment. So if I want to find out if two things are equal, I have to put two equal signs next to it. And actually, let's just do one more. If I said, if I put this in front of an equal sign, it means not equal, if those two things are not equal. So there were two more operators that we were going to talk about. But here we go. If this statement is true, this line will execute. However, if this comes out to be false at runtime, then this will get skipped, and it's going to execute this line right here. So let's run the program, put in a number, and find out what it's going to be. All right, so I'll put in a number of 100. And it says request is an even number. So notice how it printed this statement right here, but then it skipped the else. That one was ignored entirely. Let me run that again, and I'm going to enter in 101 and then push enter, and it says request is an odd number. So here, this is another example of using the modulus. All right, now let's take a look at some exercises for you to do. Okay, exercise number 1 is to output to the screen the result of adding 1 to the maximum value of an int, a short, and a long. So I want you to see what happens when you print to the screen the maximum value plus 1. And then in exercise number 2, ask the user to input two numbers. So these are two variables. You won't know what the user is going to enter. And then output to the screen the result of adding, subtracting, multiplying, and dividing those two numbers. And for that exercise, you can use ints. In the third exercise, you're going to ask the user to input an integer that represents a quantity of time in seconds. So let's say they enter in 4,000 seconds. Then what I want you to do is output the equivalent time span in hours, minutes, and seconds. Now in doing this, you cannot use any library methods. You need to be able to do this yourself. So you will determine how many seconds are in an hour, how many seconds are in a minute, and how many seconds are remaining after you've taken out the hours and the minutes. So an example line of code might be something like this. Maybe you declare a variable called minutes, and it holds the value of this evaluated expression modulus 60. All right, so that's kind of a hint in the right direction. All right, good luck with those exercises.